Good morning, folks. Good morning, good afternoon, good evening. It's Friday, and it's time for another episode of Hands-on SAP Dev with QMacro. This is episode 11, where I have a special guest whom I'll introduce shortly. Good morning, Nabheet. Good afternoon, Nabheet. Good morning, Ronnie. Good morning, Leo. Great to have you here in the stream with us. I've also got remotely Chris Whealy, who I'll introduce shortly, and also just over there is my darling wife Michelle. No, they can't. Don't worry, they can't see you. But she's scared of being on camera. She's very camera shy. So let's get going. We've got a really interesting episode today. We're still talking about the SAP Cloud Application Programming Model. But we're taking a quick one episode break from our little progress through the project we're doing, and we're going to have a look at a project that a friend and colleague of mine, Mr. Chris Whealy, has been doing. So first of all, let me switch to the interview scene here, and there we go. Let me just make that full screen and this full screen. And good morning, Chris. You're live with me and the channel.
Good morning, DJ.
Thank you very much. Channel, by the way, good. Oh, morning, Srikanth. Can you let me know positively if that you can hear Chris as well? I've got this loopback software which creates a virtual audio device from in this case Zoom. Can you let me know if you can hear Chris okay? While we wait for that, what I'll do is I'll just mess it. Oh dear, that's not.
I need to say something then, don't I? If people want
you need to say something, yes. Oh yes, works fine. Thanks, Leo. That's fantastic. I'm going to enter full screen, which gives me the ability. There we go. That's better. Yes, perfect. I've just noticed that my video is underneath the chat, so I'll have to adjust that. I'll adjust that while we're talking. I'll adjust that. So welcome, Chris. So do you want to just say a few words about yourself, who you are and everything, and what your interests are?
Yeah, long time SAPer. For the last, 5, 6 something years, I've been playing around with functional programming styles, particularly in JavaScript. Not only that language, but other languages, such as this one, Erlang. But what we're going to talk about today is how I have applied this functional programming style to a real-life application.
Mm-hmm. Perfect. Thank you very much. That's quite exciting. I've been sort of following along internally with what Chris has been doing. Although it's a personal project of Chris's, which means that it's on GitHub as well, so you can go and check that out later. I thought that we could start out, however. In fact, I'm sharing my screen here. We could start out by having a quick look, sort of warming ourselves up from a functional programming perspective, by having a quick look at something I tweeted. Have I still got the tweet? Yes, I have. A few days ago, I was doing some genuine, actual real-life work, believe it or not, internally, and I had, a lump of data that I needed to sort of transform into something else. And now, Chris, I think you've got the tweet as well. I just shared that with you a second ago, but I'm just going to share it with the folks here on my screen. And it was something that we looked at, I think, in episode 0, in the very first episode of the series, where we identified it as being an IIFE, an immediately invoked function expression. And what I'll do, in fact, is I'll just open the image up. We don't need the text of the tweet. I'll open up the image in a separate window so we can see it a little bit larger. There we go. In fact, I can move that up a little bit. So it's just so we can see Chris's face still. In fact, I can do that, can't I? Yeah, there we go. There we go. Lovely. Perfect. So, Chris, you've got the tweet and the screenshot in front of you. This is a really nice little, I called it a tick That's maybe slightly a negative word, but I meant a nice little affectation, which I really like. It's something I picked up from you, so I thought, who better to start us off and explain it than the person himself. So, Chris, can you just explain what this is doing and why it looks like that?
Okay. First of all, let's give a bit of context here. The function is used when you're doing a reduce operation on an array. So the whole point of the reduce operation is that it takes a function and applies that function to every element of an array. And the purpose of this is to build up a new value in an object, or typically an object called the accumulator. So the accumulator is any object that you want to build as a result of processing every element in an array. So when you pass a function to the array reduce operation, that function must return a new value of the accumulator. So this accumulator is the thing you're building up your value in. So if you use the standard JavaScript array.push to stick a new element into your accumulator, array.push very, well, in my opinion, unhelpfully.
Yes, unhelpfully, yeah, definitely unhelpfully.
Does not give you back the new array, the array that you've just modified by pushing a new element into it. Instead, array.push gives you back the index of the element, of the new element that's just been pushed into that array. Well, okay, that's nice. It's just not what we want. So
because we can't chain functions together, right?
Exactly. So if you want your reduce function to be a single expression where you do something and the result of running that expression is the return value that comes back from your reduce function, you can't use array.push in its native form. Yeah. So this little function that DJ's got on the screen there, this is really a wrapper that goes around the standard array.push operation, but wraps it in such a way that you can push your element into the accumulator, and the result is the new accumulator coming back. Thus, you can start chaining functions together.
What a wonderful explanation. Yes, in fact, it's probably worth pointing out as well that the accumulator, as in the thing that you're building up over the course of the execution of reduce, so reduce works on an array. So what gets fed into reduce is an array, but what gets produced is often an array, but not necessarily an array. You can actually reduce an array of a list of things into a scalar value if you wanted to, or in this case here, what we're doing is we're actually turning an array into a map. And of course, as you know, I use the word map because that's, in my opinion, the right word to use. Other people would say object, but anyway, it's the one with the curly bracket. So yeah, what we're doing here is building up a map of, if you can still see the screenshot here, of ID to status. So a status ID, status 1 needs review, status 2 is assigned for review, and so on. So that's the structure that we're actually creating with reduce. So reduce doesn't necessarily mean make smaller in this case. It's a slightly unfortunate name, isn't it, Chris?
Yeah, it's a name that potentially has some misleading consequences, but just to give a little more context, when people are new to functional programming, they've typically heard about the map and reduce operations, and without knowing anything else, they typically think that functional programming is just using map and reduce. Well, yes, but it's a lot more than that.
Yeah.
One thing I would point out, building on what you've just said there, DJ, is that the map operation is where you process every element of an array and you specifically give back another array containing the same number of elements arranged in the same order as your starting array.
Yeah.
That's what map does. You could, if you want, duplicate that functionality using reduce.
Yes, reduce is the mother of all.
Yeah, so map is just a special case of reduce.
Yeah.
So using reduce, you can return any object, any value, scalar, compound object, whatever you like. That can all be done using reduce. So I end up using reduce a lot.
I remember. I still remember, in a sort of small version of where were you when President Kennedy got shot, etc. When they landed on the moon. I still remember when suddenly it clicked in my brain that reduce was, the root function of all or many of the functional functions that I'd been using. It's just absolutely wonderful, and it's also worth pointing out. I think we briefly mentioned this also in the first episode that. In other languages, it's slightly different, but in other languages, reduce is known as fold. And there's, of course, folding left and folding right, which we probably don't want to get into right now, but it's the same idea where you're actually folding over the values and almost like knitting them together.
Okay.
Cool. Okay, so we've whetted our appetite. Yes, let's dive into some code. So that was just to get us warmed up. By the way, welcome Miles, and also Michelle Miles says hi, and welcome Robert, and welcome Christian as well. Fantastic. Okay, so I'm going to remove that tweet window. I'm going to make your window full screen, Chris, so you can go and share your screen. And theoretically, there should be a little window with your face on it as well that I can actually... What's going on? Right, there we go. There's Chris. Perfect. I can put Chris next to me. Amazing. I have no idea what I'm doing here. Perfect. So we can see your screen, Chris. We can actually see your face as well.
As we go along.
We're making this up as we go along, so no picking your nose. So off you go. Take us through. Well, do you want to introduce us to the project as it exists on GitHub, just to give people a 10,000 feet view of what it is, what the README generally looks like, and what the folder structure is, because that's how I like to start anyway.
Okay. So. Right. So the purpose of this project that I'm doing is it's actually I think probably the third invocation of a function of a application I've been working on for a while. Mm-hmm. There is a open source website called Geonames.org, and this website provides crowdsourced geopolitical data. So if you want to know about any feature, let's say you want to find all the cities in the world that have a population between 1 and 2 million and have a P in the name, you can do that by looking at the data in Geonames. Mm-hmm. So what I've done is I've written a Node.js server-side application that sucks in all the data from Geonames and puts it into a Hana database. So the CapM tools have been used to create the data model and actually build the Hana database. And cool. Then I've used regular JavaScript to pull in the data from Geonames and store it in Hana. So that's where I'm up to at the moment. The idea is then that you can build a front end that does anything you like with that Geonames data. An earlier iteration of this application uses the same data, and the front end is I have a map of the world where you can search for any town or city. The map then zooms to that city and it gives you the weather forecast for that particular location. Nice. So I haven't got... Sorry, go on.
No, I'll relay the stuff from the chat. Christian has just said about this Geonames server project. It sounds a little bit like what Wikidata is trying to do. Is that anything that's familiar to you?
Might be. I'm not familiar with that, but if you go to geonames.org, you will see that there's a huge amount of data there. This might be similar to Wikidata. I don't know.
So Geonames.org is publicly available free data, right?
Yeah, it's crowdsourced as well. So the data for each country is typically updated every day, which is why when I start my Geonames server, one of the first things it does is it looks for a new version of the country's zip file, and if there is a new version, it sucks it in. So we've got these. This is just the landing page for the server-side app, and if I click on the Geonames, all it does is give me the first 1,000 entries in the Geonames table. And I've written my own sort of RESTful API. So the format of the data that you're seeing on the screen here is an add-on for Chrome that formats a JSON response. It makes it tidy.
Yes, it's really nice.
So here, that object that you get back here, this is one row of the Geonames table. So for instance, in the, I don't actually know, I'm making this up as I go along here. In the Sydney time zone in Australia, there is a place called Toronto. I did not know this.
I didn't know
it has a population of 0, but
so we've learned something on today's live stream, folks. That's amazing. That's amazing.
So the point is, this is just the first 1,000 rows from the table. Yeah. Should you wish to be a bit more specific, I'm afraid I can't make the address bar of my browser any bigger, but you can put a query string. And look, here's one I did earlier. Yes, people who did not grow up in the UK in the 70s will not understand that cultural reference.
Yes.
So I could say, show me I've got name equals London, feature class equals P, feature code equals PPLA. Those feature class and feature codes, that didn't work. That's specific information from the data model in Geonames. So there we go. I've got a query string now that says name equals London, feature class P. All the rows in the Geonames table are categorized using this feature class. So P means population center.
Right.
So we've got a London in South Africa. We've got several Londons in South Africa. We've got the London in London. We've got London in Canada. So basically anywhere that's called London gives you the latitude and longitude, etc.
So you mentioned that these are rows from the table, but I think there's not just one table, right, in this system?
Well, let me go back here. The bulk of the data is in the Geonames table. However, we've got countries, continents, and these are the, shall we say, the more basic parts of your data model. So if I click on countries, there's one entry for every country in the world. So that's 252 countries.
Wow, check out those languages in Abu Dhabi.
The other thing that makes geopolitical data a little bit tricky is that a town or city can have multiple names, and those names can be in multiple languages. So this table here, alternate names, this is even bigger than the Geonames table, because this has, last time I looked, this has about 14 million entries in it.
So are you talking about things like Milan, Milano and Mailand?
Yes, or in Switzerland, Geneva is Genève if you speak French, Genf if you speak German, it's Geneva if you speak English. So all of those alternate names are stored in this table.
Gotcha.
And you also have these little Boolean flags here: is short name, is colloquial, is historic, in use from and to, etc.
We could use the temporal features of CAP if we were building this ourselves. In use from and in use to, that's that temporal stuff that came from HR, right? From the HR info types, which Christian Georgi showed us in episode 3. Yes.
Right. So, as I said, the bulk of the data is in geonames and alternate names. So if you read, let's say you read the geonames table, let's just pick one item at random, like that. If I stick slash and then the geoname ID, so this is the key of the field, and I can just press enter and I get that single entry back. So this is, if we go back to our qcrud concept, I've just done a read as opposed to a query.
Yeah.
I can, knowing this name, this ID, I could look up in the alternate names table and find all the. Let's just do
I
that.
dare you to pronounce that name.
I won't even go there because alternate
Wangia Duncan
names. Let's see if I can get my own. Oops, I need to. I'm making this up as I go along.
That's cool. We all
there
do.
we go.
Oh,
right.
There we go.
So I've just put the geoname ID into the alternate names table using a query string. So as you can see, we've got the name coming up in Chinese characters, multiple names. I'm not even going to begin to try and pronounce these. So there's your relationship between the geonames and alternate names table. Anyway, enough of all this. This data behind the scenes,
How is it defined?
I'm managing this data is with the coding that I've got here. Actually, before I jump in the coding, let me show you the GitHub project.
Yes, that's good.
Just zoom this in a bit.
So that looks like, I mean, it looks like lots of different projects, but the DB and the serve directories there sort of give me a little bit of a clue that it's cap, because those are the default conventional names for the persistence layer definitions and the middle layer service definitions, right?
Yeah, exactly. So I built this, actually I built this in Web IDE rather than directly locally on my laptop. The reason being that because I'm storing the data in Hana, at the moment there is not, well, let's just say there isn't a very easy way to have a local Node.js project running on my laptop that then connects to an HDI container running on the cloud platform. It can be done, but you've got to jump through some technical hoops to do that. And I haven't actually spent the time doing that yet.
But the interesting point there that I'm picking out is that while we on the stream sort of series are messing around with the Node.js flavor of cap, we're doing that sort of locally. We will move to Web IDE, but you started out using Web IDE, right? The full stack version.
Yeah, because I specifically wanted to use Hana in the background.
Yeah.
So
cool.
Apart from that, it's just a regular cap project. If we look in the DB folder, we've got the normal CDS files. So if I look in Geonames, there is a normal CDS file. So there's the data model for the Geonames table.
And I see you using the best practice naming convention there, which we've also discussed on a previous episode, which the entities are plural capitalized.
Yes. So I'm also using the title and description annotations just to make the information a bit more readable. So that's the data model defined just as you would expect any other CDS operation.
There's one thing in there that we on the stream haven't really looked at specifically yet, which is the index.cds, and that sort of reminds me that because you've got multiple CDS definition files, you have a one file to rule them all, right?
Yes. The way the CDS compiler works is that it looks first for a file called index.cds. If it finds that file, it will open only that file and compile whatever it finds in index.cds. Alternatively, if index.cds is missing, it's not a problem. It just opens every file that has a .cds extension. So
again, I love this. I love the convention over configuration.
yeah, so as soon as I put information into index.cds, that's actually a very good way of managing how I compile the data model, because let me just go back here. If I want to exclude a file from the compilation, I just remove it from IndexCDS,
Yeah.
and the CDS compiler pays no attention to it.
Nice. Nice.
So because I'm building the database in Hana, I need to use the full stack web IDE,
Yep.
its interface into the HDI container that I've previously created. So using web IDE, that's how you actually create the database in Hana. Once that's created, I can then use regular JavaScript using the CDS node npm
API.
module that SAP's released,
Yeah.
and then I can start interacting with that HDI container.
Ooh, show us that.
Right. So here is the project that I've pulled in from my GitHub repo.
By the way, folks on the stream, if you want the text, the font to be a little bit bigger, give me a shout. We'll keep it as it is, or maybe
is it big
Chris
enough?
might do. If it's too small, shout please on the chat, and Chris can make it a little bit bigger. I think it's okay, but you know.
All right. So under the SRV folder, this is where the server coding lives that actually responds. So if I go back here, so when I see this index.html file here, it's the coding in the SRV folder that actually generates this and responds to these URLs and to any API, RESTful API calls that you make from the command line. The browser address line.
So is it worth just making a distinction here between what we, as in our live stream family, have seen so far with CAP, which is, of course, apart from some sort of temporary JavaScript-based implementation of the services we've defined, the whole serving of the metadata document and the entity sets and so on is done out of the box with no code. But this is, you're serving your own API and your own responses specifically, right? That's the difference.
Yeah, the difference here is that if you use the CAP tools to generate an HTTP server, it, for instance, uses Express as the HTTP server. I'm not doing that. I've actually built my own HTTP server using the standard, as you can see here, the standard HTTP object in Node.js. This does mean that to an extent I have had to reinvent the wheel slightly, but
that's not like you.
I don't know. Unfortunately, my wheel has come out quite round. It's not square.
I thought you were going to say my wheel has fallen off.
No. Well, it did fall off during development on several occasions. But the point here is that the whole purpose of this server is to respond to API calls from the front end that I haven't actually yet developed. But I needed a server that would respond to simple RESTful calls.
Now, that's just a little segue to allow me to relay a message from the chat from Nabheat. I see a view folder. Nabheat, you missed a trick there. You could have said, I view a view folder, but you didn't. But anyway. Your front end. Tell us a little bit about
this
that.
is me experimenting. I'm afraid I haven't got to the stage yet where a view front end will sit on top of this project. So the fact that you see a view folder here, yes, that's correct, but that's actually doesn't work yet.
That's pretend at the moment.
Still working on that.
But that's the intention, right?
Yes, I'm heading in that direction, but I haven't got there yet. So, and actually, just to let let the cat out of the bag. My idea is to use Vue as the engine for driving the UI, but then to use the new SAP UI 5 web components inside Vue. I haven't
Very
got
nice.
there yet. So please, that's where I'm going with this, but I haven't got there yet. So,
Okay.
I won't go through all of this, but one of the coding styles that you will notice is, let's look at this little puppy here. That is not your common or garden JavaScript coding style. As you will notice, there are no curly braces.
Wow,
This is
yes, this
because
is. Yeah.
I am trying as best I can, and it doesn't, I must confess, it's not always possible, and I don't get too precious about it, but where possible, I try and make every function, or I try and implement every function as a single expression.
Beautiful. Yes, that's very Chris Whealy.
The reason for doing this is that I'm trying to hold to the principle that a function should do one thing and one thing only. And if problems really start cropping up in your coding if you try and make a function that was designed to do one thing do two things.
Mm.
And you then end up with what's known as scope creep, where your function was designed to do A, and then you said, but it would be so easy if it did A and B.
Yes, we can just add a little bit on to make it do B and C as well. Yeah.
And you add a bit here and a bit there, and it gets completely out of hand. And then after a while, you think, who's the idiot that wrote this?
So this is the other side of the coin or the yin to the yang of small pieces loosely joined. Sort of compositional approach to building code, right? You write small building blocks and add them together.
So let me see.
Well, actually, before you scroll down, lines 63 through 66, for example. It's an interesting pattern, and I wouldn't mind you explaining that for a second, but we have seen that on, was it Wednesday? We did a stream on Wednesday, episode 9, where we, just for the sake of it, we implemented a small function, which was a partial function, or we used function partials to filter out to only process one of the three particular entities. I think it was categories from products, categories, and suppliers. And we built this little function that took a parameter and produced a function that was taking another parameter, and so on and so forth. So, do you want to, in the context of that, Chris, can you just explain to the stream family what that is?
First of all, let me give a bit of a caveat here. JavaScript is an untyped language, which means that when you call a function, you have to take a lot of care to make sure you pass that function the right type of object. Otherwise, you're going to get some odd runtime errors. Now, this means that, for instance, if I were to pass this gen API handler an object that was not an API config object, it's going to do weird things, and I'm not going to discover that till runtime. So I have, as a way of mitigating this problem, I have developed a way of helping myself remember what type of object to pass a function, and I'm trying to be completely consistent with my variable names. And by using a naming convention, so for instance, I'm always trying to use API config as the name. So if I let me just take you in the kitchen and show you how I've cooked this up. If we go back here, I have a syntax, so I can put API v1, so version 1 of the API, and then let's just say Geonames. That is the structure of the, as you can see here, that's the structure of a RESTful call. And this call has no further parameters on it. So this is simply a query, a generic query, and it gives you back the first 1,000 rows. On the server side, I have got to build something that responds to that URL.
Yep.
So I have this config, where is it? Where did I put it? Here we go. I have this config.js file. So inside here, I have got a hard-coded object, which there's the name of the URL
to
this responds
path,
to.
yeah.
And here's all the behind-the-scenes information. There's the name of the table in Hana that I would need to read in response to receiving that URL. There's the name of the data model object in the CDS data model. And here is a list of all the query string parameters that I can respond to.
So this is almost like the, so this is the API configuration. That's why you call it API config, right?
Yeah, this object is what is going to be received by the Gen API handler. So API config is that great big object that I've just showed you. Now, let's look at the structure here. I've got a function called Gen API handler. It takes a single parameter, API config, but it does not give me back a value in terms of a static object or anything. What it gives me back is an entire function.
So a function that produces a function.
Yes. So this is known as a partial function. It's partial in that the complete evaluation of the arguments has not happened yet.
Yes.
That's why it's called partial, because I have not fully evaluated all the argument values simply because I haven't received them yet. So the function I get back, this function itself takes 2 arguments. And so I'm now getting into the HTTP handler part of the coding. So I first of all say, what URL have I received? This is the URL coming in from the incoming HTTP request. And recognized URL config, this is an object that says, do I recognize the URL I've just been passed?
Yep.
I might do, I might not. The user might have typed in complete nonsense, in which case this that object will not contain any information. So if we look at this, go back to this config here, for every URL that I could respond to, I've got an individual, let's get rid of this.
Yeah.
I've got an entire config object. So look, I've got alternate names, countries.
So the recognition type mechanism is basically, can I find it in this map here?
Yes. Now, the reason the coding is written in this partial function style is that I need to have multiple Gen API handlers. Or sorry, an API
multiple handlers, yeah.
So this function generates another function that will respond to each one of the objects listed here.
Very nice.
What this means is, again, let me take a step back here. The principle that I'm following here is coding is bad if you have to write the same piece of code twice.
Dry.
So this, yes. This is really an abstraction of every object in this config, great big config file here. So in one sense, this is kind of like a finite state machine, in that I have a list of all the URLs that my server will respond to. If it receives one of these URLs, fine, I'll process it. If it doesn't receive this URL, it doesn't crash. It just says, I don't recognize that.
Yeah.
And gives you back an HTTP 404. So this is an abstraction across every object in the config file. and it gives me back a function which, if we look inside the body of the function that is returned, we now see a slightly different structure.
I can think of
The
4
body
letters.
of the function is inside parentheses, and I've got another block of parentheses here. This is one of these invoke, what do you call it?
Immediately invoked function
expressions,
expressions.
yes. Now, you could argue, well, you don't actually have to do this. You could put this in curly brackets and then declare a local variable called validate URL and say validate URL equals whatever this is. But I'm trying as much as possible to keep the principle that a function is a single expression.
Also, it sort of reminds me, when I was starting out my journey of functional programming, some of the code I ended up writing that I was happy with felt, and this is the phrase I thought to describe it, felt like solid state code. It doesn't move. It doesn't wiggle around.
There's no loops here. There's no trying. One of the problems of the traditional for loop is that you, as the programmer, are responsible for keeping track of some sort of index counter that says this is how many times I've gone around the loop.
Yeah.
In functional programming, the focus shifts from how you do something onto
what you want.
What you are doing. Exactly. And this is the what of my functionality. This is what I want to do. How many times is Gen API handler called? Well, I don't really care, because in fact, it's going to be called once for every object.
Yeah.
I just scroll up to the top here. This API v1 is as an object with multiple properties in it, and I can loop around all the keys. This is a key in this, so object.keys dot reduce, and now I can process every property in this object without needing to care, first of all, how many keys there are, and I don't have to care about keeping track of how many times I've gone around the loop, because I'm using the reduce function.
This is why help the computer to do what it should be doing out of the box. Like you say, don't tell it how to process a list of things. Just say, I want this list of things processed, and say that in an expression, which is a fundamental philosophy that has helped me understand a little bit about functional programming. It just by the way, we're using object.keys in our little data grabber function that we completed yesterday. I know that some people were around yesterday, and also Wednesday as well, Wednesday's live stream. So we used object.keys, which is again a way of saying, well, just give me all the keys of this object, of this map, which is really nice. I just noticed actually before we jump to where you just were, without going into too much detail, is it mentioning the sorry, I was going to say the C word. Is it worth mentioning currying?
Yes. Let me think. Well, this particular function, this Gen API handler that we've been looking at, isn't curried.
No, it's not.
Sense, but okay. Can I just go back to the
use of course. Go.
So, as we've said, here is a function Gen API handler. So the purpose of this is to create a function that will respond to. Let me go back here. So when you put in a URL here, I need to have a specific function that responds to that particular URL.
Yeah.
So let's go back here. This function is responsible for generating the functions that respond to the URLs the user could enter. So if I right, so here is now, if we take one step further back in terms of how we're setting up our HTTP server, I've got gen request handler. So here we're using object.keys. Look at this. config.urls. So if we go back to our config object and scroll right down to the bottom, there is my URLs property. So depending on whether I'm running in development or production, which is something you can pick up from the Node.js environment, I'm going to have a set of URLs. And these URLs are this great big long list of objects that we've seen here. So here I'm looping over every URL in my config object, and I'm using the map operation to assign a request handler. And I've got I've made a difference between two types of URL. One is a link that comes from the HTML web page, from the landing page, and one is a RESTful API. So again, the way the coding is structured is that I've written functions that abstract the creation of functions. So this is functions creating functions that will respond to everything that is presented in this config object.
Yes.
So now, once I've got this, if you like, this is like a hierarchy of functions. So gen request handler calls assign request handler. Assign request handler calls gen API handler using the current element from our URLs object.
Mm-hmm.
So once I've established this, shall we say, a pattern of behavior, I can quite easily add an entirely new URL to my API simply by creating a new one of these objects, giving it a new URL, putting in, the appropriate configuration, and then without having to change a single line of code, I've expanded the API for the server.
It almost feels like simply by
changing the configuration.
Yeah, I mean, it almost feels like we're in this sort of strange land between programming and configuration, where actually where you've got some building blocks using I'm going to use this phrase, using higher order functions that either take and or produce other functions, so concept from functional programming. So you've got the building blocks that are, again, solid state, which will then allow you to program, quote unquote, your actual API by supplying config, by writing code in the form of configuration. And
exactly,
that is really nice in that configuration doesn't move either.
No. So as I mentioned earlier, effectively what I've built here is a functional finite state machine.
An FFS.
It will respond. Yes, it will respond.
Sorry.
Well, that tickled you. It will respond to basically anything you throw at it, but it won't crash if you throw it garbage.
Exactly. While we're here, I'm noticing in your quest to write in the form of single expression functions, in lines 81 through 85, something that Ronnie, I think Ronnie's still around on the channel, will delight in. You're using not only ternary operators, you're using a nested ternary operator.
Yes.
I do like the ternary operator.
The point here is to avoid using the if statement, because as soon as you use the if statement, you've introduced a
statement,
a long language construct that is by definition not a single expression.
Yes, exactly. You're moving away from thinking in terms of expressions that are evaluated towards statements, which would possibly lead you down the path back towards sort of imperative programming.
Yeah. Now I must just to be open here, I have not entirely used this style everywhere in the coding, simply because it's actually much easier. So here is the actual request handler. This is the object that is, this is the first unit of code to be executed in response to that URL.
Gotcha.
So here, there's your standard request response objects. If you've done HTTP programming in Node.js, you'll recognize this structure.
Yeah.
But notice also, this is a partial function. When I call HTTP request handler, I pass it, first of all, the default response object. This means that what I get back is a function that can handle any HTTP request, but hard-coded within it is the value of default response, which is seen down here. And this means that I could, should I need to, reuse this function and simply supply a different value for default response, which means, as it says here, this is the landing page. So this default response contains the HTML for, hang on, this page here.
Yeah, yeah. Lovely. By the way, in the chat, Napit says, talking about finite state machines, he never thought that his college education would haunt me like this. I guess that was covered in his education.
Oh, you mean he is slightly upset to realize that
be reminded of it.
Taught at school. A, he's been reminded of it, and B, it was actually useful.
Yes, exactly. I'm just conscious of the time. We've got 9 minutes left. I would love to. I mean, you jumped down to somewhere that actually used some of the CDS API. Because my question was going to be, when you do get an incoming request, how do you use the CDS API to respond to it?
Okay. When the server starts, the first thing I have to do is connect to Hana. So I've got this connection object which contains the connection details for how to get to my Hana HDI container, and that comes from here. This is my connection object.
I recognize that expression.
This is one thing I had to pick up when you tried implementing this. I'm using a productive Hana instance, and you're using a Hana trial, and it didn't connect for you because I hadn't put this bit of coding in here. But again, here's a functional approach.
Beautiful.
Rather than saying, if the person has a Hana instance, then else. If the person has a Hana trial instance, do something else. So I'm overloading the OR operator, and the way the OR operator works in JavaScript is it gives back the first truthy value.
Yes, it's what's the phrase? It short circuits, doesn't it?
Yes, it short circuits. So I put in, let's say, if I'm using a Hana productive Hana instance, then I get back whatever the element of this array is. If this value turns out to be undefined is a falsy value. It coerces to Boolean false, which means I'm automatically going to get that value.
Yeah, exactly.
So you've either got a Hana trial instance or you've got a productive Hana instance. Anyway,
nice.
Kind of digressed there. I do this a lot. Right, so we connect to Hana, but notice how these method names are structured. It's one great big chain of thens.
Promises
so this immediately
everywhere.
Tells us we're using promises. The CDS connect function gives me back a promise because it's going to take some time to actually communicate with the HDI container. That runs actually, compared to the data center where I'm running my Node.js object, Node.js server, my HDI container is actually running in a completely different data center. My productive Hana instance. So this call is asynchronous, which is why it's wrapped in a promise. At such time as I get my connection, Then I will generate the request handlers.
That's so much cleaner than using the old callback approach.
Oh, you would disappear into callback hell and
very
never be
quickly.
seen again. So this is where I'm setting up my HTTP server to generate all the functions that are going to respond to the various URLs that it could receive. The next thing I do is this is a direct SQL statement. And what I'm doing is I'm reading the countries table to obtain a list of countries.
Yep.
The reason I'm doing that whatever this function gives me back, that becomes the argument to the next stage of my processing. So then I get a list of countries, and for each list in the country, what am I doing here? Oh, I'm just defining the landing page. Oh, yes. And this list of countries is passed through to the next then. And here is where I go off to the Geonames website. And so here's my list of countries.map. So for every country, I'm calling, we haven't looked at the loader program, but this loader is the JavaScript module that goes off to Geonames and pulls in the zip file that is specific to that country, and then puts that data into Hana.
Beautiful, beautiful. I noticed you're using L there. Is that your style? I think my equivalent is X, but EL is also something that's it's like something, some item.
Yeah, X of X's, isn't it?
X over X's, yeah.
L, that just means element.
Yes,
so
exactly.
When you call the map function for every element in the map or the array that you're mapping over, I just called it L.
Yeah, no worries.
What the L?
Oh dear. Oh, very nice, very nice. Hey, listen. We're almost at the end.
Yeah, we're almost out of time, and I could waffle on about this for hours. So,
but to be honest, it doesn't matter, because we could do another session if folks are interested. Thanks, Christian. You've got to go. That's cool. We're almost at the end anyway. Just in finish, I know this is I would love to go on, but I want to keep this to an hour, so we could have you back. One thing to note, or to remind ourselves of, is that if you've not seen it already, in our little data retrieval function or data retrieval script that we've been building in the other episodes recently, that uses also the promise chain .then. So if you want to sort of hit the ground walking rather than running, as it were, you can have a look at that script that we've been building in the previous episodes 9 and 10. But also, I just wanted to have a look at line 225 there. So 225, you're effectively enabling the promise chain to continue by passing the country list value to the next then, right? That's what that's doing, isn't it?
Yes. So in this block of processing, the functionality that I'm performing here is actually synchronous.
Yeah.
I can create an HTTP server on the fly. I can sort the list of countries on the fly. None of these are asynchronous operations.
Yeah.
So I need to do that functionality at this point in time, but because I'm working in a promise chain, I have to
wrap it effectively.
Package this in my own promise, which is then returned. Otherwise, I couldn't chain it to another then.
Fantastic.
So in this case, my list of countries, I'm doing a little bit with it. I'm sorting it, and then I'm passing it through to the next step of the promise chain.
And again, not trying to do too much in that previous function.
No.
Right. Mr. Whealy, thank you so much for joining us. I'm getting some messages on the channel. Oh, by the way, Mahesh, you have a non-CS background. You're hearing about state machines for the first time. Don't worry, you're in good company. I don't have a CS background either. I did classics at university, and neither does Chris. And Nabheat says another session would be great. And VU Dawson, great to hear, and blah blah blah. Would love to hear more. Promises Dominoes, yes, Promises Dominoes. I like that phrase. So, Chris, you will tweet the URL to the GitHub repo where this can be found, and it just goes for me to thank everybody for joining and asking some really good questions. Ronnie, you've got no CS background either, so in fact, yes, this is all good. None of us. That's really cool. Yeah, there's the GitHub repo. Chris Whealy /Geonames_Hana. And with that, thank you so much for joining and making this interactive. Thank you, Mr. Chris Whealy, for joining us as well. And have a great weekend and see you next time.
Ciao.
Ciao.